Welcome to our presentation for our work MakamCycle. Before we start, we'd like to thank the CompMusic community for having us here, and Barış Bozkurt specifically for taking on the task of single-handedly organizing this whole workshop right here. We're from University of Mons in Belgium, from the TCTS lab and the Numediart Institute. Our main area of work, personally, is not music information retrieval, so you're kind of outsiders to the field, but we believe we can touch on the side and maybe have some meaningful collaborations. So our work today that we're going to present is called MakamCycle. And it's a tool aimed at improving the understanding of music, and the term understanding is a bit vague, but we'll come to that. So here's a brief outline of the talk. We'll start with the scope of the work and goals. So as I just mentioned, our goal is to create an interactive tool that is aimed at browsing a data set of audio data, and mainly browsing by similarity. And to create that thing, we set our goals to, we first want to make the case that such a tool is useful for Turkish music, Turkish Makam music, and also maybe eventually other areas of music. And we want to convince you that this kind of tool could be useful in your research. And our second goal is to create a proof of concept specifically for Turkish Makam music. And as you all probably know, Turkish Makam music can be categorized by different factors, like form, usul, or makam. And makam is a set of complex rules for improvisation and composition that include both pitch intervals, intervallic structures, and also melodic development. And as part of CompMusic, we've all had the privilege of listening to masters and experts on this. So I kindly refer to you to those talks for further information, and stop right here before I say something wrong. And here's a not comprehensive, but recent list of works that focus on processing Makam music of Turkey. It's encouraging to see that even though the research community is very small, the scope and the quality of the works are very high, and it's encouraging to, move forward in this field. We are making use of mainly Barış Bozkurt's work in this work, but we'll come to that also later. So as you've just seen that, okay, this is not comprehensive, but it's also not far from comprehensive either. There is really not too much work going on in processing Turkish Makam music. On the other hand, on the Western-oriented MIR tools front, there is so much that you need charts and diagrams to even display a small subset. So here we show you some representation of Western-oriented MIR tools, and we find it meaningful to look at the tools in a 2D plane of geeks and researchers. Researchers is obvious, but by geeks we mean like hands-on people who get their hands dirty and plug things together and make them work in the real world. As I'm guessing most of us are researchers, we are kind of stuck in the top left corner, and because that gives us a lot of power and flexibility. We rapidly get our ideas in code, we see the results and so on. We see the numbers as results, but on the top right corner it's very attractive because that's where the real world stuff happens, like real world data, metadata, user contributed data, interactions, nice user interfaces, animations, all this fancy stuff. And it's very attractive because we've got these things that work mathematically, but we just want to have that little extra something, that real world interaction we want. But often the top right corner is a whole another beast that needs its own education, that needs its own discipline. So we try to get our stuff from the top left to the world of the top right, but we often end up feeling like this because it's difficult. So we thought, we could provide something in between for researchers to, get their tools, easily put them in something, fancy and movie and colorful, sorry. And we believe that this could be useful for researchers. So to do that, to reach that goal, I'm sorry, I can't see my mouse. We propose to use the MediaCycle framework, which is an existing framework from our institute. And here's a brief introduction to it. It explains everything way better than I can tell about MediaCycle. Okay, so it's a framework for rapidly creating modular apps for processing most of what comprises digital media these days, text, image, audio, video. So we want to make use of this. And okay, just to make our case clearer, what kind of app we want to build with this framework and with the motivations we had earlier. So we propose a playground approach for our app, and by that we mean, you should be able to directly play with the results of your algorithms on the data set. You should be able to see the relationships and how they change as you change parameters directly and without, waiting for processing to end and, trying to read numbers and trying to make sense of them. Large data sets can be very tricky to understand and get insight on. So what we want to do is we want to tap into the unconscious brain where there's tremendous processing power, but unfortunately it doesn't speak the language that we speak, which is abstract and formal, but the subconscious brain doesn't speak it. So to get it to do what you want, you have to speak its language, which is sensory information. And in our case, in a computer app, in the app that we're proposing, it's mostly visual sensory information, which is like color, movement, shapes, and so on. And we believe this kind of representation and this kind of interactivity will help create a mental model of the data set you're working on and the relationships between the algorithms, the relationships between algorithms themselves and the data set, and how they change. And we believe it will help create an insight, faster than usual methods and create a deeper understanding, hopefully. And to do that, we start with modifying AudioCycle, which is an existing application built using the MediaCycle framework. So it's not as simple as this, but just for our purposes, we can summarize AudioCycle as an application that takes in a database of audio. It extracts various features from it, audio features. It then clusters them, for now using only k-means, but it's modular, so you can change the clustering as well. And after the clustering, it visualizes the clustering space in a way that keeps the distance relationships intact. So when you extract a lot of features, you have an n-dimensional space, and you do clustering on this large dimensional space, but your visualization space is only 2D, limited by the computer screen. So you have to find the visualization algorithm that takes the relationships from that multiple dimensional space and maps them to the 2D space. in a correct and meaningful way. And by that we mean keeping the distance relationships and also keeping the clusters together so you get an idea of it. And there are also multiple visualization algorithms built into MakamCycle. And it's also modular, so you can add your own visualization algorithms. And after the visualization, it's up to the user interaction, where the user can change the parameters of the audio features, disable and enable which audio features are used, change the clustering, etc. And so we took the MakamCycle from Numediart and part of Makam toolbox from Barış Bozkurt. Specifically, we're using the pitch histogram method from that toolbox, which I won't go into the details of, but it basically generates a histogram of pitches, which is used in classifying the Makams. And we made a very straightforward implementation. And the M file is called at runtime through an octave wrapper, and the returned result of the M file, the MATLAB script, is taken into the MakamCycle app, well, MakamCycle now, and displayed accordingly along with other features. So, and it's flexible in this way because it's very simple. If you just want to implement your own audio feature, you just put an M file that returns a vector, and that vector will be used as an audio feature in MakamCycle. So, as per results, we created this app you mentioned, and we believe we can learn about things in iterations, in incomplete iterations. If you learn a bit at every iteration and you do enough iterations, enough cycles, that you'll eventually gain a better understanding of it. And we look at this in an integrated way. Like how you do research is also connected to what you learn about the data. So the steps we are conceptualizing for this cycle, for this iteration is, first we start with what is the theory of Makam music. Then we think, are there algorithms that can recognize aspects of this theory? Can we make this run, integrate it into something? And we need to visualize this through MakamCycle. How can we easily make these run? How could we present the results interactively? And what do people think about the resultant app? Which is where you come in, as users and also as researchers. So all that talk is about this app right here. So I'll give you a small preview of the app. Okay, so all the circles represent one audio file each, and you can click on them to get an audio preview. You can listen to it and see the waveform. And there it was clustered according to energy, and we disabled it, and now we're clustering according to the Makam histogram, the pitch histogram of the Turkish music file. And there you see it's clustered. You can increase the number of clusters to see how the clustering changes. You can add other features to the clustering which are simultaneously clustered with the other audio features. You can change the weight of each feature in the clustering to see how much each feature plays into positioning the files on the space. Yeah, and you can get audio previews of each file as you go along. So we believe this kind of interactive way could be useful for researchers. For future work, we want to standardize the plugin interface and make it as flexible as possible and as comprehensive as possible to provide a hook for the most number of users. We want to add more clustering and mapping algorithms. There are some already built in the MakamCycle and MediaCycle framework, but there's always more to add. We want to add richer visualization of audio and audio features, like spectrum maybe along with the waveform. The possibilities are very many. We want to add support for importing previously extracted features because a lot of people have already calculated features like in the internal discussions we mentioned the SNTL library and the results are stored as YAML files. It would be good to just import them and use them directly. One caveat about this application is MediaCycle isn't yet released and the licensing is pending, and As much as we'd hate to see it not be GPL, it may actually end up not being GPL. So in that case, since Octave is GPL licensed, we may have to abandon the Octave wrappers and find another interface for all this. And yeah, thank you for your attention. This was our work. Any questions, we'd be happy to understand. More importantly, we would like suggestions, because we want this tool to be used by the community. So we would love your feedback. Thank you.